Hello everyone who is watching this video lecture. So in this video lecture series, we will be understanding the basics as well as analysis and design part of various type of concrete structures. Concrete structure means we will be covering RCC structure basically as per the syllabus of the BTech Civil Engineering, and this subject will be having two parts. In this semester, it will be Design of Concrete Structure, Part 1, and later on in the coming semesters, we will be switching over to Design of Concrete Structure, Part 2. So, first of all, let us try to understand that what are the contents or curriculum of this subject, that is DCS 1. So, we have divided this subject into various units. In Unit 1, we will be covering some information regarding the properties of concrete, and you have already studied the subject concrete technology. So in this unit number 1, we will be just brushing up your knowledge in some different way so that we can understand the basic properties of concrete which we can utilize or we can exploit in designing and analysis of concrete structures. Unit 2 will be covering the design and detailing of reinforced concrete beam. So Unit 2 will be devoted to design of RCC beams. There may be various type of beams. And Unit 3, we will be able to cover design and analysis of some slabs as well as staircase. Unit number 4 will be subjected covering compression members, that means axial columns, or there may be other type of columns. So whatever be in your syllabus, accordingly we will be covering the topics. And Unit 5 will be based on the footings, where we will be going through different types of footings, what is the role of footing and what are the various forces which will be coming on the footing, and how to do the analysis as well as design of basic footings. Now, since you have already studied in the previous semester the subject concrete technology, which were in very detail, that means you have covered detailed information about various properties of concrete, maybe fresh properties, that means fresh state concrete properties as well as hardened state concrete properties, and what are the various factors on which these properties will depend. And you have already gone through the concrete mixed design methodology also. So here we will be in Unit 1 going through the properties of concrete in such a way that how we can utilize this information in the analysis and design of RCC structures. As we are very well aware, everybody knows that throughout the globe, concrete is the most useful material because of its basic properties and easily available material. So concrete can be prepared from locally available material which are easy to get, and we can exploit their properties as per our requirement. So let us go through some definitions which you have already studied in concrete technology subject, some basic definitions. So very first term is cement paste. Now you can understand that what is the meaning of cement paste? That means it is just suspension of cement particles in water. Cement particles are suspended in water, and that type of material is known as cement paste. Then we will discuss about the mortar, and mortar is, now you have added fine aggregates in the cement paste. So in simple language we can say mortar is suspension of fine aggregates in cement paste as per our design methodology. And next is concrete. Now what we will doing in concrete, we can say it is suspension of coarse aggregate in cement mortar which we have already prepared. So that means there are basically three type of materials. One is paste, other is mortar, and the third one is concrete. And accordingly they have their different properties. Now concrete can be further divided into, or you can classify concrete just as normal concrete. Normal concrete means it is just a simple cement concrete which we use in normal construction work. That means in simple construction work, not a specialized type of construction activities. Then second type is reinforced cement concrete. Now you can see here cement concrete is reinforced with some material. So we can just improve the properties of cement concrete by reinforcing some material. In the earlier years, you can say maybe 100 years back, cement concrete was actually lime concrete. So that time you can reinforce it with bamboos or straws or any other type of material which can reinforce them, so that we can just improve the properties of cement concrete which properties that cement concrete is lacking. So later on you will be able to understand more effectively. So reinforced cement concrete is cement concrete plus reinforcement. That means here in our syllabus we will be reinforcing cement concrete with steel. So steel bars will be embedded in the cement concrete, and that composite material will be termed as reinforced cement concrete. More popularly, it is known as RCC. Then another special type of concrete is fiber reinforced concrete. You can say it is FRC basically. So here what we are doing, we are using additionally some fibrous material. Fiber may be of many types. They may be of steel fiber or polypropylene fiber or any type of fibrous material. So what we are doing here, we are using fibers, or we are adding fiber to the cement concrete. And other special concretes we can prepare so that we can modify the desired property of concrete as per our requirement by using some admixtures or some special type of material which can improve the properties which we want to improve of ordinary cement concrete. Now the properties of concrete which we are more interested in the design part. So first of all, very important property of every material, that is strength of the material. Whether it is a cement, whether it is concrete, whether it is steel or any type of material. So our main focus is first of all to explore what is the strength of that particular material. So here our focus will be on strength aspect or strength property of concrete. So in general, strength of material, any material, is basically a measure of the amount of stress required to fail it. Or in other sense, we can say what is the maximum stress which we can apply to that particular material so that it should not fail. So that maximum stress will be the strength of that particular material. Now in case of concrete structure may be subjected to direct compression, as in case of actually loaded columns, or there may be some tension or flexural stresses. In case of beams, beam will be subjected to flexural stresses. So various type of stresses will be there in case of concrete structures as per their utilization or as per their role. Now what is concrete? It's a very simple concept which we have to understand so that we can easily exploit their properties. So first of all, we have to define what basically concrete is. So we can say concrete is a composite material. So concrete is a composite material that consists of mixture of hydraulic cement, aggregate and water. These are the three basic materials. First of all, you need some hydraulic cement, that means cement which can give some chemical reaction when water is added to it, so that it can give the binding properties. And the second thing is aggregate, and aggregate are of two types, fine aggregate as well as coarse aggregate, depending on the size of the aggregate. And third important part is water. Now these other things, you can prepare concrete only with the help of these three materials, or you can add some admixtures, some fiber or other cementitious material if you are interested in improving the basic properties of the concrete. And some cementitious material you may add some fly ash, some slag, silica fume, micro silica, and various other type of materials you can add on, and they will be termed as just as admixtures. You can even replace some part of the cement with some other material which will give similar or better binding properties. So here we are able to understand that what is concrete? Concrete is a composite material. So that means when concrete is getting hardened, then it will behave as a composite material, as a another different type of material. Now it will not be only cement or aggregate or water. Now very important assumptions which we take in the utilization of concrete. Now we assume that concrete is a homogeneous material. Now we are well aware that in general concrete at sites is prepared by hand mixing or some other mechanical way of mixing, and we are not sure whether you can prepare the homogeneous material. So to use its properties, to understand its properties and its utilization, first of all we have to assume that it is a homogeneous material so that we can assess its various properties. Now, as the term concrete, now let us understand concrete is basically a term which is originated from Latin word concretus. Now concretus means to grow. Similarly, concrete is expected to gain its strength till the process of formation of heat of hydration products happen. You are well aware that in concrete, cement react with water and it will produce some heat, and that process is known as hydration process. Now this cement will get hydrate and new products will be formed, just like CSH gel, and those material, those hydrated products will be having some binding properties, and those material which are now prepared having some binding property, what they will do, they will bind aggregate and other admixture, etc. So that means it will be binding all the ingredients, and now you will get a hardened material. and that hardened material is known as concrete. Initially it was cement paste, then it became mortar, then now this mortar will be able to catch or bind all these aggregates to form a hard material, just like a rocky material. So sometimes concrete is also known as artificial rock. Now, in case of properties of concrete, very important property is compressive strength. As we know that concrete is such type of material which has very good compressive strength, very high compressive strength, and that compressive strength even you can change or you can modify as per your requirement. Now first of all, let us understand this compressive strength of concrete, because concrete is a composite material, so it will depend upon, or you can say it will get influenced from the constituents materials. So that means what are the ingredients. So compressive strength will directly depends on the ingredient, not only ingredient but also their relative proportion will influence the compressive strength of the concrete. In general, the size and quality of ingredient mean aggregate, cannot guarantee, so there is possibility of variation in strength of concrete even in same ways. That means if you are preparing a batch of concrete and you are using same aggregates, same bulk of aggregate, even then you can't guarantee that that batch of concrete will have the same compressive strength, because no aggregate is your aggregates are not of same size, or you can't ensure that each batch of concrete will be having exactly similar type of aggregates, because aggregates may be having size less than 20 mm like that means size of the aggregate varies from 4.75 to 20 mm. So you can't be assured that in particular batch of concrete, or you can say if you are preparing suppose 10 cubic meter volume of concrete, you can't say that in each cubic volume of concrete aggregates will be of same quantity or same property. So what I want to say here, that if we have prepared 10 cubic meter of concrete, then there is the possibility of variation of compressive strength of each cubic meter of concrete. That means if you are taking some sample from a single batch of concrete and you are casting the cubes, then you may find that every cube will be showing some different type of compressive strength. So how to overcome this? Then we will be using now what we have mentioned here, keeping in notice the above issues. We have used a term that is known as characteristics compressive strength. So in actual, we are not calculating the compressive strength of a batch of concrete, but we will be terming it as characteristics compressive strength. It will be worked out for design purpose, and this characteristic compressive strength is based on the use of statistical data, and this statistical data and this characteristic compressive strength is as per the guideline given in IS 456. So here what we are understanding, that means if you are casting a number of cubes, suppose you have casted 100 number of cubes, then each cube may have variation in compressive strength. So to make utilize of concrete and to understand the exact compressive strength, we will be using the term characteristic compressive strength, not the compressive strength. Now what is characteristic strength? As per statistical tools, characteristic strength is defined as the strength of material below which not more than 5% of test results are expected to fall. So later on we will be able to understand it more effectively. Now you can see here one graph that is known as bell curve. Now here in the horizontal axis or along x-axis there is compressive strength, and along the vertical direction, that means along y-axis, we have taken the density of the number of tests. Now here we can take the example. Let us suppose we have casted 100 number of cues. So 100 number of cues you have casted, and then you will be making a table, and where you will be tabulating the strength, compressive strength you obtained from each cue. And then using the statistical analysis, as we have done in mathematics, you may be finding that most of the cues, or you can say, now see here in this graph, here 40 Newton per mm square is the strength, and what you are able to see here, that most of the cues are giving the strength of 40 MPa, that is 40 Newton per mm square, and some of the cues may be giving 35, some of the cues may be giving 30 MPa, some number of cues may be giving 45 MPa, some number of cues may be giving 50 MPa. So what we are observing here, that a bell type of curve is formed. Now as per statistical tool, what we will be doing, we will be trying to just shade here 5% of the area. Now you can see here the shaded portion is of having 5% of the area of the whole curve. So at this 5%, as per statistical analysis, not more than 5% of the test result are expected to fall. So from this figure, we can say that characteristic strength of this lot of concrete is 30 MPa. So it is very much clear from this graph that there are some number of cues which are having strength of 40 MPa, some of the cues having strength 35 MPa, and effective characteristic strength is 30 MPa. So characteristic compressive strength can be defined as strength of the concrete below which not more than 5% of test result are expected to fall. And here you have to take care that testing of Q sample should be as per the specifications or guidelines given in IS 516. Thank you. So here we are able to understand that what is the meaning of characteristic compressive strength and why we are using the value of characteristic compressive strength instead of actual compressive strength of the Q. Now, concrete is basically designated in terms of its characteristic compressive strength, which is a symbol we use is Fck, and we can designate it as ordinary concrete, standard concrete, as well as high strength concrete. Now, all this information you can refer table number 2 of IS 456-2000. This table will give the guideline for different grade of concrete as per their classification. So this is table number 2. You can go through here. In table number 2, in IS 456, grade is mentioned. So here in first column, group, that means concrete is divided into some groups, then grade designation, then characteristic compressive strength of 150 mm cube size at 28 days, in Newton per mm square, more specifically as per the guideline mentioned in IS 516. Now, very first part is ordinary concrete. So what code has mentioned? Code has just listed M10, 15 and M20. That means up to M20 grade of concrete, it will come under the ordinary concrete. And correspondingly, their characteristic compressive strength is 10, 50 and 20 MPa. Now after that, from M25 to M55, all these grades are in mentioned as termed as standard concrete, and correspondingly they have their compressive strength, which is known as characteristic compressive strength in MPa, that is megapascal. Beyond M55 grade of concrete, these type of concrete are known as high strength concrete. Now here you can see the note that concrete is designated here M. You are well aware M is for mix and 10 is for the characteristics compressive strength in Newton per mm square, and this is the compressive strength obtained from 150 mm size cubes at 28 days of strength, 20 days of casting in as per Indian standard. Now second note mentioned in table 2 is the concrete of compressive strength greater than M55 design parameter given in standard may not be applicable, and the value may be obtained from special literature and experimental results. So you can say that this IS 456, it is better or they have the application up to M55 grade of concrete. Now another table, very important table in IS 456 is table number 5. Now what information is table number 5? That minimum cement content required, maximum water cement ratio, minimum grade of concrete. So we are more interested in minimum grade of concrete for different exposure conditions and with a normal weight aggregate of 20 mm nominal size. So you can see here in the first column some exposure conditions which are mentioned as per IS 456, that mild condition, moderate condition, severe, very severe and extreme. And correspondingly, as we are more interested in a reinforced concrete, because most of the design detailing will be for the reinforced cement concrete, so code has very clearly mentioned that what should be the minimum grade of concrete. So minimum grade of concrete in case of RCC structures, because we are more interested in RCC structure. So referring this table number 5 from IS 456, we are able to understand that minimum grade of concrete in RCC structure is M20 for the mild exposure condition. So as you go to the other type of exposure condition, that would moderate severe, you can see here the minimum grade of concrete as recommended by IS 456 will go on increasing. Now another important property of concrete is tensile strength. We know that concrete is very good in compressive strength and has poor tensile strength. So that is, concrete is very weak in tensile strength, approximately 7 to 10% of the compressive strength. Now here there is, I can say that there may be one question which you can work out or you can find from the sources of information available from some standard books, that why tensile strength of concrete is so that it is just as 7 to 10%. That means why concrete is so poor in tensile strength in comparison to compressive strength. So you can just go through the literature from some sources, and when you find this answer, you can just put in the comments. Now, since there is concrete is very weak, as we have already told in the tensile strength. So direct tensile strength is not possible for calculation of tensile strength in case of concrete. So another ways we will be using, that is some other methods to just know the tensile strength. And as per code has advised us some information, some formula. That means for the design purpose, you can use that formula to calculate the flexural strength. And that formula is in clause number 6.2.2 of IS 456, where FCR is equal to 0.7 square root of FCK. FCR means flexural strength and FCK is characteristic compressive strength of concrete under consideration. That means if you have concrete of 40, that means M40 grade of concrete, then FCK will be 40 MPa, and you put the value here, you will be getting some value for the flexural strength, which you can utilize in design of the structure, design of RCC structure. Now another important property of concrete is modulus of elasticity of concrete. Again, for design purpose, code has given some information, and that is code has recommended this formula to just estimate the elastic modulus. That means modulus of elasticity. EC is modulus of elasticity of concrete, and that is given by this formula 5000 square root of FCK. For this you can refer clause number 6.2.3.1. So E is modulus of elasticity of concrete and FCK is characteristic compressive strength of concrete under consideration. If you have any type of doubt after going through this video lecture, you can just ask in the comment section as well as in the regular class. Dear students, in lecture 1, we have gone through in the discussion part of properties of concrete which are related to design of concrete structures. We have already discussed what is the compressive strength, what is characteristics compressive strength, tensile strength. Now today in lecture number 2, we will be discussing, first of all, we will be going through to understand what is the stress-strain relationship of concrete. Then next topic will be stress-strain relationship of concrete when duration of loading is greater. Then maximum compressive strength of concrete, which we have to consider for the design purposes as suggested or recommended by Indian Standard Code IS 456. So first of all, let us focus on the stress-strain relationship for concrete. You have gone through about the stress-strain relationship for steel, that is mild steel in strength of material subject. Now we have to understand effectively how the stress-strain relationship develops for concrete under different conditions. So let us try to understand the stress-strain curve particularly for concrete. Now most of the cases we are focusing on the concrete structures as a compression member. So stress-strain curve for concrete under uniaxial compression we will be taking care of, because most of the time we will be working on the compressive strength of the concrete when load is axial compression or uniaxial compression. Now in the right side you can see a graph. That graph is a relationship between compressive strength of the concrete. Strength or stress, they are one and same thing, so it is along y-axis. there is compressive stress in megapascal, and along x-axis there is the strain. So this relationship is very helpful for all of us to understand that exactly what is the meaning of relationship between the stress and strain in case of concrete. Now you can see here there are three graphs we have shown, and each graph belongs to a different grade of concrete. So different type of mix is under consideration. Now you can see this graph number 1. In this graph number 1, you can observe the behavior or the curve you see, and in this curve, some part of the curve is just like a straight line, that is a linear relationship, and after that you will be observing there is a curve. That means now linear relation just has been removed, or you can say now linear relation will not follow. After that there is non-linear relation, and at a particular level of the stress or corresponding to the strain, you will see there is a maximum compressive stress. Maybe in this curve you can see here is the maximum compressive stress, and that maximum compressive stress corresponds to a particular value of the strain. So here, if in the first curve you can see the maximum strain, where the maximum stress is in the concrete, you can observe that maximum strain value is 20 into 10 raised to power minus 3. And similarly, when you see the other diagram, that means other curve, this is curve number 2. Now what we have seen here, the grade of concrete has been changed now, and this mix has different proportions. And similarly, there is another third curve where. So what we have to understand here, that with the change of grade of concrete, you will be finding that there is some variation in the stress strain graph of the concrete, which we will discuss now. Now, as we have discussed, there is a linear curve during the initial phase. Everywhere you will find that some part of the curve is a linear curve. That means it is just like elastic curve, and you can consider that up to this limit, concrete behave just as a elastic material, and after that it is not elastic, it is an inelastic type of a material. So linear part of the curve during very initial phase of loading. So earlier phase of loading, where strain is, you can observe here strain is approximately 5 into 10 raised to power minus 3, and stress corresponding is 7 MPa. Similarly, from this graph we can analyze that when the strength of the concrete is increasing, correspondingly graph or you can say relationship is changing. Now let us talk about the non-linear portion. So what you will able to see here from this diagram, that non-linearity, when the stress level exceeds between 1/3 to 1/2 of the maximum stress. Now you see, suppose the maximum stress is suppose 35, then in between 1/3 of 35 or 1/2 of the 35, that is the maximum stress or maximum strength of that particular grade of concrete, you will find that the curve is non-linear. So that means a relationship, now it is not an elastic relationship. And another important point which we have to keep in mind, that whatever be the maximum value of stress, and each curve you will find that peak value of that curve, that stress strain graph for different type of grade of concrete, you will find the maximum value of the stress will be corresponding to a strain, that is 20 into 10 raised to power minus 3, or you can say when the maximum strain is equal to 0.002, corresponding value along the stress axis, you will find the maximum value of the stress. And for in general cases, or for usually, there is a range of concrete strength and the strain failure. You will be seeing here, if we just go through the curve number 1, after the maximum stress value, which is corresponding to strain 0.002, and you will find that strain is increasing and what stress is decreasing. So this will be the behavior of the concrete, that when you will be just seeing that strength now don't increase with the increase in the strain. So that's why we have mentioned here that strain, after that value strain, if this graph, suppose it continue like this, then you will find that the failure mechanism, or you can say the concrete sample, will getting failed when the strain range is beyond 0.03003, or you can say 0.003 to 0.005. In that particular range of the strain, the concrete may you observe to be getting failed. So these particular value of 0.002, which is very important for all of us to understand the complete mechanism of the concrete. Now, if we talk about the Young modulus of elasticity, which is a constant, and it is defined as the ratio of stress to strain. So that means if suppose in this particular type of concrete, you want to find out the Young modulus of elasticity, then what you have to take? You have to take the ratio within the elastic limit. So if this is the elastic range, within that elastic range, when axial stress to axial strain under uniaxial loading. So when you have to calculate Young modulus of elasticity, you can just take the tangent value of this, and accordingly you will get the Young modulus of elasticity. And corresponding, there may be a little bit change in the Young modulus of elasticity, which directly depends upon the type of loading and the duration of the loading. So in this particular type of graph, which is just available when you are crushing the concrete cube in a CTM, that means compression testing machine, and you will find that the failure of the cube will take hardly 5 to 10 minutes. So that means you are applying the load on the cube of the concrete just for 5 to 10 minutes, and you will be finding the failure of the concrete, and accordingly you will be calculating the compressive strength of the concrete. But in general, when concrete is used in the construction, that means in the RCC structures, then concrete or that structure will be subjected to loading not only for 10 minutes, but maybe for 1 year, 2 years, like that. So now we have to understand the stress-strain relationship for concrete when duration of loading is greater. It may be 1 year, 2 years, like that. Then whether the behavior of the concrete will change, or whether there is variation in the stress-strain relationship for concrete, that we will be able to understand now. So stress-strain curve for concrete under greater duration of the loading under uniaxial compression. Now, when concrete is subjected to loading at a slower strain rate, such that the duration of the loading increased as much as 1 year or more. So that means how will be the behavior, or how will be the relationship between stress and strain when the loading is for a longer period of time. So now we will be going through the details. So when you draw the stress-strain curve, when the load is acting for a larger time period, you will find a slight reduction in the compressive strength, modulus of elasticity, and a significant increase in the failure strain. Stress strain curve becomes relatively flat after the maximum stress is reached. In the previous diagram or previous graph, we have gone through the stress strain curve, and you can find that the stress strain curve was a linear relation up to some uh, stress level. After that, it will be a parabola, it will be a curve type of shape. And after the maximum stress level reached, the curve is again, it is just like a curve. Now, but in this case, is this type of loading, when the loading is for a longer duration of time, the stress strain curve becomes relatively flat after the maximum stress is reached. Now, in this diagram, you will be able to understand along y-axis there is stress, along x-axis there is strain. Now, different type of curves you are able to see. Now, very first curve is when the loading is applied just for a 10-minute of a duration, which we have already discussed in the previous graph. Now, if you increase the duration of loading, it may be 1 hour, then 1 day, 1 month, 1 year, you will be finding that this curve is getting somewhat flat. That means this curve is just moving upward, and here you will be finding it just a flat curve. And let us suppose the loading is for more than 1 year, maybe for 10 years, 20 years, you may find the curve just like this for a larger duration of time. So that is the major concern here, because wherever you use the concrete in the construction, that structures will be subjected to loading throughout its life period. So how they will behave, how the stress strain relationship will develop, that we have to understand effectively before going through the design aspect. Now, what is the important observation here? Very first point is the compressive strength of concrete is an actual concrete structure, as I told, because ultimately concrete is used at a site in various type of structures. In when you are testing the concrete, you will be just casting the cubes of a standard size 150 cube, and that will be also tested under the standard conditions in the laboratory. But when you have to use that concrete in actual conditions, then you can say the size of the members of the structures or component of the structures, just like there may be a huge column or beam or slab, their size will be comparatively 1,000 times or 100 times greater than the size of a cube. So that's why this is the important point. Whatever be the compressive strength of the concrete you are getting after the testing of the cube, that may not be applicable, or that may not be properly usable in case of huge structures. So we can say the compressive strength of concrete in actual concrete structure cannot be granted in comparison to laboratory results, which are under standard conditions and controlled conditions. So that means we have to do some alteration in the this compressive strength, which you just have collected the information in the laboratory. Now, in addition to all quality parameters, whatever you adopt, other factors such as effect of the duration of the loading, which we are in discussing just now. Similarly, size of the member, that means there will be some size effect, and the strain gradient also affect the strength properties in a real use. So in next slide we will be understanding it more effectively. So in continuation, these are the important points which we have just discussed. Now this curve we have already discussed. Now what code suggests us? How code is giving some guidelines, that means what will be the compressive strength of concrete you got from laboratory test, how it can be utilized, or is there any modification or amendments. Now you can see there is a graph in the right side, and this graph is taken from IS 456, that is figure number 21, stress strain curve for concrete, uh, which code is recommending. Now you can see here what we have already told, that up to strain 0.002, the curve is just like a non-linear part, and at a strain level of 0.002, maximum stress is reached, and beyond that we have just considered in the earlier section that the stress strain graph will be just like a linear, or it is just like a flat curve. So you will be observing here. Now we will be focusing on first two curves. This curve we will discuss later on. Now this curve will give you the value, that is Fck characteristic strength of the concrete. That means this is the relationship between the stress and the strain when characteristic strength is to be taken into consideration. So it is very much clear that this curve belongs to the results obtained in a laboratory testing of concrete cubes. So the value of maximum compressive stress of concrete. What will be the value of maximum compressive stress of concrete? If you are getting this value after even applying the statistical parameters, you get the value of Fck. But what will be the maximum value of the compressive strength, which you can take into calculations by keeping into consideration the above all the parameters? That means effect of the duration of loading is taken into consideration, size effect of the actual construction, you can say construction site or construction elements under consideration, and the third point is strain gradient, whatever we. So all these parameters if we take into consideration, then what IS 456 is suggesting us, the maximum value of the compressive stress of concrete which you can take into consideration while designing and doing the analysis part. And for design purpose, you can refer clause number 38 of IS 456, so which give us the value that compressive strength of concrete will be equal to 0.67 times Fck, where Fck is characteristic compressive strength, which we have already discussed in detail. So what you have to do, you have to multiply it with 0.67, and whatever the value you are getting, that will be the maximum value of compressive strength of concrete which you can use while designing the structures. And later on, when we will be going through the design philosophy, we will be able to understand what will be this third curve belongs to. Thank you. Okay students, in the previous lecture 1 and lecture 2, we have discussed the basic properties of concrete like compressive strength, characteristics compressive strength, tensile strength, flexural strength, as well as the stress strain graph for concrete in case of loading, in which we have studied two type of loading criteria. First one was when the loading was for a small duration of time, that happens in the concrete testing in laboratory, and then we have discussed how the stress strain graph will vary when the loading is a consistent loading and for a long duration of time. So today in lecture 3, let us see what will be the content. So here we will be going through the information regarding creep and shrinkage, and then this lecture will cover some information regarding the design methodology of concrete structures. particularly our focus is on reinforced cement concrete structures. So let us start it. Now we have gone through behavior of concrete under sustained loading for a longer duration. So in continuation to that, we have to understand that how concrete behave, or you can say concrete structure behave just as a beam or a slab, RCC structural elements. So behavior of the concrete when it is subjected to sustained loading for a longer duration of time, which happens in the practice. That means when you are going to construct a building or any RCC structure, and after getting the hardened, when concrete get hardened, and later on when that structure is in under use, that means during its service life, then it will be subjected to various types of loads for a longer duration of time. Some of the loads may be fixed load, which we generally call them as dead load, and as well as another type of loads are live loads. So what is basically creep in concrete? Now, as we have discussed in the previous lecture 1 and 2, that there is a gradual increase in strain with time, which you can just review from the stress strain graph. So when a concrete member is subjected to sustained loads beyond elastic strain, then what will happen? Then we can understand that another important aspect is creep strain. That means it is time dependent component of strain. Component of strain mean, if you just recall the stress strain graph, in that stress strain graph, initial part of the graph was a straight line type. That means it was a linear relation. So that linear relation gives us the information about the elastic behavior of the concrete, and the corresponding strain in the elastic range, that is known as elastic strain. And beyond that, behavior of the concrete will not be elastic, it will be inelastic type of behavior. So time dependent component of the strain, where we will be including the strain due to shrinkage as well as temperature stresses. So when you exclude the strain due to shrinkage and temperature stresses, then how that curve will be giving us the information, and that type of strain which is time dependent, that means it depends on the duration, that strain is known as creep strain. So it is very much clear that creep is a form of strain. Now from this picture, that is a sketch of the graph between the strain and the along x-axis we have taken time since application of the load. That when a load is applied, and we will be counting the time duration and how the concrete will behave and how strain will be seen in the concrete. So you can see here up to this particular limit, or you can say exactly up to this limit, here load is consistent and there is a strain, and the strain up to this limit is known as elastic strain, because it is just a elastic part of the curve, a modified part of the curve. So this is the strain when load is within the elastic range. That type of strain is elastic strain. Now you can see here beyond this particular point, the graph is just like a parabola, or you can say it is a particularly curve shape. So this curve shape you will see here beyond the elastic strain, which we have already mentioned here. Beyond the elastic strain, the strain which you observe, that is known as creep strain, and that is due to the creep behavior. Now after that, the graph will be reaching somewhere here. And now let us suppose the load is removed, that means unloading take place. Then the graph will be just you will see it is a dropout, and this type of graph, that means when you have just removed the load and there is unloading of the member, sudden drop you will observe, and this type of sudden drop we will say it is instantaneous recovery in the strain. And after that graph will be just as you can see here, it will be parabola and so on. So first of all we have gone through, that is first one is the elastic strain, then second one is the creep strain, and after unloading there is instantaneous recovery, and after this instantaneous recovery there is it will take some time to recover in the creep, so to reach its initial stage. So this is known as delayed creep recovery, that means it is not instantaneous recovery, so it will be taking some time. And after that you are observing here strain is almost remaining constant, so it means some creep strain just remained within the member which is termed as residual creep strain. So from this graph we are easily we can understand that how concrete behave under sustained loading with a longer duration. Now this creep strain is much larger than the elastic strain on loading. So this is the important point. Now elastic strain we have discussed that what is the meaning of elastic strain. Then creep strain we have gone through, elastic strain, creep strain. Then during unloading, instantaneous recovery, delayed creep recovery, and the residual creep strain. So all the information we have discussed. Now you can refer clause number 6.2.5 of IS 456 2000 to just get the information on what factors this creep of concrete depends. So I'm not going into more detail of the creep strain because it is expected that you have gone through it in detail in your earlier subject, that is concrete technology. So in currently I have just gone through this strain because many times when we are going to design a structure, then we will be just remembering or recalling the creep. So this is the reason so that you people can understand what is the meaning of creep. So creep is basically a strain when the concrete member is subjected to sustained loading. That means loading remains sustained for a particular duration of time. So every structural member, every RCC structural member will be finding some strain, and that strain will remain within that member. So that is basically residual creep strain which we are interested to understand. So on what factor the creep of concrete depends, you can just go through and read this clause number 6.2.5 of IS 456. And in that IS 456 you will be finding some table, and that table is under clause number 6.2.5.1, where it is clearly mentioned that in first column age of loading and creep coefficient, and you can observe here at 7-day creep coefficient is 2.2, at 20-day 1 year you will find that creep coefficient is on decreasing trend. Now what are the major effect of creep of concrete on RCC structure? That means how the creep of concrete will be influencing the design parameters of RCC structures. So very first point, very important point is, when you are going to design any RCC structure, then you will be first of all interested that how much deflection is will be occurring in the member due to the loading. So here the another effect of creep on concrete is it will increase the deflection of structural element such as beams and slab. So it will be increasing the deflection. It will increase the deflection in slender columns. As well as when we are talking about the pre-stress type of concrete, which is not currently in our scope, but just for the purpose of knowing the information, that means there will be some loss of pre-stress in pre-stressed concrete due to the creeps. So that's why concrete is very important factor which we have to understand before going to design any RCC structure. Now another important aspect which we have to understand that is shrinkage in concrete. Now from the name itself is clear that shrink means there is some decrease in volume. So due to volume changes in concrete, now there may be some of the regions, maybe due to temperature rise, volume may change or volume may increase, decrease, etc. So shrinkage is the another factor which is very important. Shrinkage of concrete. Now let us understand. Strain can also rise in concrete due to change in humidity and temperature of the surrounding with time. You are aware when a structural element is constructed in any type of building, RCC type of structure. So then what you can easily understand that with the change in duration as well as time, even with the change of the, or you can say during the day and night, you will be finding some temperature variation in day and night. So these type of humidity may change, temperature may change. So it is wrongly written here strain. It is basically strain. So strain can also arise in concrete due to change in humidity and temperature of the surrounding with time. Now concrete shrink in its hardened state due to evaporation of water due to any region, maybe because of change in ambient temperature. So what will happen? This will reduce the volume of concrete. When water is evaporated, then volume of concrete will reduce, and due to that some drying shrinkage will take place. And if restrained, if that means if that particular structural element is restrained to shrink, then what will happen? There will be cracks or deflection, and that type of cracks are known as shrinkage cracks. Earlier we have gone through creep, now it is shrinkage. So cracking due to shrinkage of concrete, they are known as shrinkage cracking. Drying shrinkage, as we have discussed, will lead to micro cracks, and when the concrete structure is prone to micro cracks or some cracks are emerging in the concrete member due to evaporation of water, it will definitely influence the strength of the concrete. That means it will weaken the concrete structure. Shrinkage also induces time-dependent strain. Let us go through the graph. Now you can see here along y-axis it is shrinkage strain, and along x-axis there is time duration. Now this time is calculated after 7 days of moist curing. So from this graph it is clearly visible as the time is increasing here, shrinkage strain is increasing. So here what we have written that shrinkage also induces time dependent. That means the shrinkage strain due to shrinkage also depends on the time, that means which we can see here, and after a particular duration you may find that the curve is getting almost flattened. Now here you can take the help of IS code 456 and clause number 6.2.4. So okay, so Clause number 6.2.4 of IS 456 can be referred again for factors which creep of concrete depends, as already we have discussed. Now, effect of shrinkage of concrete on our system, what will be the influence? So first of all, as we have discussed, if there is any type of shrinkage, then concrete will try to just get shrink, and if it is restricted to shrink, then stresses will develop, and it will increase the internal stresses, deflection as well as curvature. So it will be directly influencing the geometry of the structural element. Again, loss of pre-stress in pre-stress concrete structure will also be due to the shrinkage of the concrete. Now here, another point which we have to keep in mind, shrinkage can be minimized by reducing water cement ratio, by increasing the total aggregate content, and controlling the evaporation of water in the concrete. So here, later on you will be able to understand that how evaporation of water can be controlled. That's why we are using the curing of the concrete. So curing method is, if curing is done effectively, then you can just control or reduce the shrinkage effect on the concrete. Now, let us go through the reinforcing steel which we use in concrete, and that's why concrete members are given a new terminology, that is RCC, reinforced cement concrete. So as we have discussed in the earlier lectures, concrete is good in compression but very poor tensile strength. That means concrete will be behaving just or you can say it will be poor in taking the tensile stresses, and whenever there is a structural member which is made up of RCC, it will be subjected to flexural behavior, that means bending behavior. So when the loads and forces are acting on the member, it will be under flexure. So that means it will be under bending, and when a member is getting bent, then one part of the member will be under compression and other part will be under tension. But if that member is made up of concrete, as we know that concrete is weak in tension, then it will not be able to take care of all the tensile stresses, due to which cracks will observe in the member. And when cracks are there, definitely strength of the member will reduce and your structure will not remain durable, and there are very significant chances of failure of the structure. Now what we do to enhance the tensile strength of concrete, that means tensile stresses carrying capacity of concrete. Now you can see here in the figure. So first figure, figure A, what you can see, there is a beam member, simply supported beam member, and it is suppose it is another member, then member will be under flexure and you will find some flexural cracks. So steel reinforcement, which are good in compressive and tensile stresses, we know that steel is very good in compression as well as tension to take care of the compressive and tensile stresses, because it has ductile nature, it possesses ductility. So steel reinforcement, that means steel bars are embedded in the concrete. In this figure you are able to see, suppose in first figure where only concrete member was there, and here what we have done, we have just embedded a steel bar. Now when load is coming on the beam, you will be able to see that only some hairline of cracks are there, and when load is further increased, then its behavior will change. Now you can see here, when load is when you are increasing the load, and later on at some stage you will be finding some minor cracks, and some minor cracks, that means This steel member, due to its ductility, it will be starting yielding when load is beyond the yield point. So that means in figure A and figure C, if you compare, figure A will fail at the load which we are applying on the in the figure C. So that means what you can see here we have shown only a single load, here we have shown three number of loads. So you can easily compare figure A and figure C. That means in purely concrete structure, it can take a very small amount of load, but same beam, when a reinforcement is provided, now it becomes a RCC beam, then its load carrying capacity is significantly improved. Now steel bars to be used in concrete should form a good bond with concrete. Otherwise it is useless. If it is not forming a good bond, then steel will automatically get ejected from the member. So it is very important to assure that there is a good bond between steel bar and concrete, for which they should be very much clean and free from loose mill scale, dust, loose rust, and any oily material. So that means steel bar should be free from any type of rusting material, so that the steel bar can effectively get bonded with the concrete. And after that, steel bar as well as a concrete, they will act as a composite material, not as individual material. Suitable treatment may be adopted to get the reinforcement clean. That means you can use any type of just like sandpaper you can use, and if there is any scales or any dust is seen on the steel, or you can just by using the sandpaper you can clean the reinforcement before embedding it in the concrete. Now few points which are very important: physical and mechanical property of these different type of bars which we can use. First of all, we can use mild steel and medium tensile steel bar, which is termed as MS bar, which conform to IS 432 Part 1 1982. So you can use mild steel bars. You can use high yield strength deformed bar, commonly known as HYST bars, which are conforming to the guidelines given in IS 1786. Then hard drawn steel wire fabric conforming to IS 1566. So there are various type of steel bars available, and which are conforming to different type of codes. So you can use these type of steel bars in concrete. Another type of steel, structure steel conforming to grade A of 2062. So any type of steel as per your requirement you can use as a reinforcing material. For more detail you can refer clause number 5.6 of IS 456, and you can refer special publication SP 34, where table 1.1 give all the related and important information regarding the steel bar which you can use as a reinforcing material in RCC structures. Now let us have some brief information regarding the design of RCC structure. When you are going to design any RCC structural element, just like RCC beam, RCC slab, RCC column, footing, etc. So first of all, we must be clear that what are the objectives of design. If you are clear in the objectives of the design, then you can design accordingly so that all the objectives can be met out. Now, what is the main objective? Main objective of any structural designer is to produce ductile behavior in RCC member, such that it is available to safeguard human life. Because if the material is brittle, suppose you have designed a member which is brittle, so when load it is subjected to service load, then at a particular point it will collapse. So brittle material will collapse and the whole building can collapse. But if the member is truly ductile, then what will happen? It will be, when it's subjected to loading, what will happen? It will start bending. And when there is a bending, that means before failure of any structural component, it will give us a lot of burning. That means just on viewing that structure, you are able to understand that, and later on it will be going to fail. So failure can be avoided. So that means when you are going to design a structure, its behavior should be ductile behavior, which will give sufficient warning sign. Now, structure design must satisfy some basic requirement. So, very first is stability. Your structure must be stable. Stable means any type of overturning, sliding, or buckling of the structure or any part of it under the action of load should be prevented. Otherwise, its stability will lose and the structure will not remain stable and a failure can occur. Second important aspect is strength of the member. So structural components should be of sufficient strength so that they can resist the various type of loads, forces or movements which are going to happen due to the service loads when it is under the utilization. Third, very important is serviceability. Serviceability means when the structure is exposed to service load. And so we are saying it structure should perform satisfactorily for the intended purpose, for the purpose for which purpose it is built. So it should fulfill all the purposes. Its performance should be very much satisfactorily under service load condition. That means it should have adequate stiffness, which is required. And if there is any type of deflection, crack width, permeability, etc., then these type of happenings, that means deflection, crack width and permeability, it must be within permissible limits, and these permissible limits are clearly mentioned in various Indian standard codes, just as IS 456. Now, what are the design methods which we can use, or design methods which are adopted and are currently in practice? So first of all, our guidelines will be available in the code IS 456. So what code is saying? You can use the limit state design method. That means limit state method of design of RCC structures as per IS 456 recommendations. Secondly, you can also use the earlier method of design, that is working stress method, but code is saying that wherever limit state method cannot be adopted conveniently, you can use working stress method. Otherwise, currently or in these days, we have to adopt this limit state method of design. In the later lectures, we will be able to understand that what is the difference between working stress method and a limit state method, and which one is better, and if any one is better, why it is better. Now, some basic codes which you have to be kept with you when you are going to design. So some of the important codes, first of all, we know that it is IS 456 2000 version, plain and reinforced concrete code of practice. Now, how to estimate the various type of loads which can occur? That means how to assume the loads. So some guidelines are given. There is a series of codes IS 875. In part 1, information regarding the dead loads is given. In part 2, imposed or live load information is available. Part 3 is devoted to wind loads wherever structures are subjected to winds of high velocity. Part 4 is devoted to snow load. Part 5, special loads and load combinations. Later on you will be able to understand in all the details. And whenever you have to design a structure so that it should be earthquake resistant, then you have to refer the guidelines given in IS 1893-2002. Thank you. Hello learners, today is lecture number 4 in the subject design of concrete structures and unit 1 properties of concrete. So in today's lecture we will be able to understand that what is working stress method of design of RCC structures and limit states of limit state method of design. So these two methods we will be discussing today. As in the lecture number 3, you remember we have gone through and we have discussed what are the objective of design of RCC structure. So we have discussed some basic requirements, that means a structure should be stable, having sufficient strength, as well as it should be having satisfactory performance during the uses. That means when that structure is used by the occupants or the purpose for which it was built, so it should perform all the functions comfortably. And the two methods we have discussed, that one is limit state method of design, which is currently in practice, and earlier there was working stress method, which even we can use wherever limit state design method cannot be adopted conveniently. Then we have discussed that IS 456 we will be referring in case of plain and RCC structure, reinforced concrete structure. So this code of practice will help us about the guidelines which we have to follow and to make a structure safe and sound. Then how the loading calculations can be done, that means how the load values can be assumed to work out the stresses as well as the design of the RCC structure. Now today in this lecture, let us discuss what is the working stress method of design of reinforced cement concrete structures. So first of all, we have to understand the philosophy of the design by this method, working stress method. So let us understand it more clearly. In this method, it is assumed that the structural material, in our case structural material will be concrete, that the structural material behaves in a linearly elastic manner, and that adequate safety can easily be achieved by restricting the stresses in the material. That means when a material will be having, suppose we are talking about the steel, then steel has yield stress. Similarly, the material, other material which is in practice, that is concrete. So concrete has some compressive strength, which we have gone into detail in the earlier lectures. So what we have to do, we have to restrict the stresses, or you can say we will be taking some reduced value of the stress, so that whatever be the expected loads will be subjected to the structure, which are known as service loads. So it is assumed that the structural material behave in a linearly elastic manner. This is our assumption in working stress method, and we are restricting the stresses so that whatever be the load on the structures are coming, they will not fail the structure basically. Now these specific, after restricting the stresses, we will say that we will be obtaining the value of permissible value of the stresses. That means whatever be the value of the stress, which we term it as allowable stress, are kept well below the material strength and within the elastic limit. So whatever be the material strength, and accordingly we will be allowing only permissible stresses. For example, if we say concrete is of M20 grade of concrete, for example, so 20 MPa will be the strength of the concrete in compression, and as per this methodology we will be just reducing that strength for our calculation. Let us take the concrete of strength, suppose it is 20 MPa, and we can take it allowable only 10. So that means 20 MPa strength of concrete, that means concrete of 20 MPa strength will be just assumed as having a 10 MPa strength. So for this 10 will be our allowable permissible stress and 20 will be the actual strength. So what we have to decide, we have to take care that whatever be the stresses coming on the structural element, that should be well below the material strength. The stresses under applied loads will be analyzed by applying simple bending theory, which we have already gone through in strength of material. Everybody is well aware about the simple bending theory. Now it is also assumed here that steel reinforcement and concrete, they both act together and are perfectly elastic at all the stages. So here this assumption leads to the observation that steel and concrete will be acting as a composite material, and they will behave as a perfectly elastic. This is the assumption in the method of working stress method. Now fourth one is next one is stresses in concrete and steel are assumed to be linearly related to their strain. So that means it is also assumed that the stress strain relationship for the material is a linear relation. So that means stress in steel is linearly related to that in the adjoining concrete. So that means when you embed the steel in the concrete, and when it get hardened and subjected to some loads, and due to that load some stresses will be developing, and here it is assumed that stress in steel is linearly related to the concrete in which it is embedded, and then we will be using a factor of safety. Later on we will use factor safety. So this relationship will be known as modular ratio, and it is written as M, symbol will be M. So compressive stresses by concrete and tensile stresses by steel, this is the another assumption that all the compressive stresses will be taken care by concrete and all the tensile stresses will be taken by steel. However, we know that steel can also take some compressive stresses, but here in this method we will be assuming that whatever be the compressive stresses on the member, they will be taken care by concrete, and whatever be the tensile stresses, they will be completely taken by steel. Now let us discuss modular ratio. Modular ratio is basically the ratio between modulus of elasticity of steel and concrete. That means it is a ratio which will be just giving the relationship between modulus of elasticity of steel and concrete, and it can be used to determine the stresses in steel and concrete. Now here other important assumption is we will be assuming that there is strain compatibility will be in the member. That means strain will be equal in both the materials. Now ratio of material strength, as we discussed, to the permissible stress will be termed as factor of safety. Now we can understand it that permissible stresses will be yield stress, which is the material stress, divided by factor of safety. So For example, if you are taking a steel of a grade maybe Fe 250, so then its yield stress will be 250 MPa, but you will be dividing it some factor of safety. It may be taken as 3. So permissible stresses will be 250 by 3. So it means the steel which is we are using in this concrete in RCC member, we are just considering the yield strength of steel now when it is embedded in concrete is 1/3 of its actual strength. So that will be the permissible strength. So another point is the stresses caused by these service loads. So whatever be the stresses coming on the material due to the service loads, that means the loads which are coming on the structure, they will be checked against the permissible stresses. So this line indicates that whatever be the stresses coming on the material, so that stresses must be less than the permissible stresses. Permissible stresses is the highest limit which we can allow in case of working stress method. Now let us discuss few limitations of working stress method. Very first limitation is we are assuming in working stress method that concrete is a elastic material. But in actual practice, in lecture 1, 2, 3 we have discussed, in actual practice concrete is not elastic material. It is basically possessing inelasticity, so it is inelastic material. So that means this is the drawback of the or a limitation of this working stress method. Now second important limitation is factor of safety which we are taking, that will be taken only for stresses. That means we are not taking into consideration loads. Factor of safety is not taken for loads, it is only taken for stresses. That means it will not give the real information about the actual strength. Third limitation is in the working stress method we don't discuss anything about the shrinkage and creep. So far we have discussed the working stress method, and working stress method not clearly indicate that what are the provisions we have taken for concrete when it is subjected to loading and shrinkage and creep stresses will develop. And we have discussed that shrinkage and creep stresses are also time dependent and plastic in nature. So here working stress method is silent about the stresses which may develop due to shrinkage and creep. Another important point is this working stress method will give uneconomical section. Why it is uneconomical? Because we are using higher factor of safety. Factor of safety for concrete will be taken as 3 and for steel it is taken as 1.8. So why we have taken 3 for concrete and 1.8 for steel? That you may have studied in strength of material also, that concrete is man-made material, that it will be prepared at site. So we are not sure about the quality parameters which will be adopted at the site. Also we have discussed in the previous lecture that concrete is supposed to be a composite material, and we are not sure about every ingredient of the concrete which will be having same quality, but still we can manufacture in the factory. So in factory we can control all the conditions. That means quality control parameters are more stringent in case of factory made products. So that's why we have taken lesser factor of safety in case of steel and a higher factor of safety in case of concrete. So here you can easily understand that by applying a factor of safety of 3, we are actually reducing the strength of concrete by 1/3 when we have to do the calculations. So actually, if suppose M30 grade of concrete is there, then strength of concrete will be 30 MPa, but by dividing its factor of safety by 3, we are just considering the concrete of 30 MPa is having strength only 10 MPa. So that's why we have to use more quantity of concrete as well as more quantity of steel. So due to that, it will be giving us an uneconomical section. Fifth point is there will be no information about the behavior of structure during service life. That means when the structure will be subjected to actual loading, that means when people will be start occupying that structure and some live loads will be acting on it, and how it will behave after the construction, and what type of parameters, like whether there will be any leakage, etc., cracks, etc., and permeability, durability. So all these information are not available in working stress method, because working stress method is mainly focusing on the strength of the structural element, but not about the behavior of the structural element after when it is in practice. So IS 456 recommend now that is limit state design method for RCC structure, and you may use working stress method in the design, but then you have to face all these limitations and you have to compromise on some of the properties of the structure as well as the economy. Now let us discuss what is limit state method of design of RCC structure. So first of all, we have to understand what is the philosophy behind limit state method of design. Now you can see here the name of this method is limit states. So limit states mean you are talking about some states or positions where you are limiting some information. That means something is limited here. So as the name limit state is used in limit state method instead of failure. Here we are not using failure word, but we are using the limits word. Now we can understand it more effectively. The limit state method use multiple safety factors which attempt to provide adequate safety at ultimate loads as well as adequate serviceability at service loads. So earlier in working stress method we were concerned about only adequate safety, but here in a limit state method we are using additional safety measure, that is adequate serviceability at service load, by considering all possible limit states. So that means here we are again talking about that limit state method is linked to limit states. So what are the limit states? What type of limits we are imposing in case of limit state method? Let us go through. The selection of various multiple safety factors. Here we are using multiple safety factor. So how to select the multiple safety factor? What will be the value of the safety factor? Later on we will be terming them not as only safety factor, they will be partial safety factor, is based on the sound probabilistic analysis. That means it is based on the values will be worked out on probability analysis by considering different kind of failures. So here we are talking about different type of failures, different type of material and different type of loads. So based on all these things, that means type of failure, type of the material and type of the loads, we will be selecting the safety factor. So in working stress method we were not talking about the type of the loads. There was no safety factor or factor of safety we can say for loads. So what is limit state? Limit state is a state of approaching failure. So that means we are not getting the structure here failed. So failure word is removed, but we will be saying that it is the state, limited state, when the structure is just approaching the failure. Structure is not getting failed, beyond which a structure ceases to perform its intended function satisfactorily. So what we are saying that we will be adopting or providing or limiting something in the design, some parameter in the design, such that any structure, when it will reach beyond that particular state, limit state, we will say now structure is not performing its function satisfactorily. In terms of either safety, you can say now structure is not safe. Maybe structure has not fallen or has not collapsed, but we will be saying that beyond this limit, this structure is neither safe nor serviceable. That means you can't use that structure. It may either collapse or become unserviceable. So what is the possibility? Possibility is that whatever the limit we are imposing, beyond that limit may be some particular stress, either the structure will collapse or structure will be unserviceable. That means you can't take the services of that particular structure. Now, regarding limit state method, you can refer a whole section number 5 is devoted to this methodology, limit state method. It will start with clause number 35. You can refer IS 456 section 5, which will start with clause number 35. So now we have to understand what we were talking in the previous slide, that there are some limit states. So what are the type of limit states? First of all, we will say it is limit states of collapse. That means when structure will be approaching the collapse. Structure will not collapse, but it will approach the stage of collapsing. So you can refer clause number 35.2 again from IS 456. Now let us understand it more effectively. The limit state of collapse of the structure, either structure or any part of the structure, could be assessed from the rupture. So there may be, when you see some rupture in the structure or some component of the structure, then you will say now this structure is approaching the limit state of collapse. So now when you see rupture, then you will say the structure is approaching the limit state of collapse. Because if there is any rupturing in the structure component, that does not mean that structure has failed. So it can be assessed from rupture of one or more critical sections and from buckling due to elastic or plastic instability. That means if there is any buckling, that means buckling just like bending, in case of any structural component of that structure, that means structure has not collapsed, structure is not getting failed, but it is just indicating, that means it will be the indication that later on it can collapse. So main focus is in this method is, that means we are not designing the structure for failure, but we are designing the structure by imposing some limits during design such that structure will never collapse, because we will be imposing limit. So that means when you will be seeing any type of behavior of the structure, then we will be saying that it is approaching the limit state of collapse. So here we have discussed number one, there may be any type of rupture, there may be second point any type of buckling, and third there may be any type of overturning. So this is limit state of collapse. It comes under the clause number 35.2. So what we have to do in the case of limit state of collapse, the resistance to bending, shear, torsion, because resistance to bending means it will be, we are just relating it to buckling, or we are relating it to rupture. Shear means there may be some rupture, some cracks can observe. Torsion may result into overturning, so they are interrelated terms. So the resistance to bending, shear, torsion, and axial load at every section shall not be less than the appropriate value at that section produced by probable most unfavorable combination of loads on the structure using the appropriate partial safety factors. So here we are terming it as partial safety factor. So limit state of collapse means we will be designing a structure so that it can resist the bending, shear, torsion at any section due to any adverse type of combination of loads. So our structure will never fail because we are just treating it before any type of failure is possible. So then again, second type of limit state is basically limit state method. First of all, we have discussed limit state of collapse. Now limit state of serviceability, which you can refer in clause number 35.3. So it means when your structure is just constructed and it is ready for the use or ready for the occupancy, and when that structure is occupied, then what will be the behavior of the structure so that people should get occupy it safely. So here we have to understand the limit state of serviceability deal with discomfort to occupancy. That means if the occupants are feeling any discomfort, then we will say the structure has reached limit state of serviceability. And what type of discomfort? It may be caused by excessive deflection. That means there may be excessive deflection in the structure. Suppose there is a beam or there is a slab, it may get some deflection, but that deflection may be allowed. But if it is excessive deflection, then everyone who will be just looking about that structure, they will not be happy with the structure and they will feel discomfort, and their uh, confidence on the that component of that building will not be there. So they will not be able to utilize that structure effectively. So what type of discomfort? It may be due to excessive deflection. There may be excessive crack width. If you find some cracks in the any type of structure, if there may be a slab, then you will be trying to move away from the slab because it will your confidence will be losing. Any undesirable type of vibration, leakage, etc., or loss of durability. So that means this will be the limit state of serviceability when you feel any type of discomfort due to any type of regions. So that means when you are going to design a structure and you are taking care of limit state of serviceability, then first of all you have to be sure that there should not be excessive deflection, there should not be cracks of greater width, or you will be restricting particular width of the crack, or there should not be any type of vibration, leakage, as well as loss of durability. So all these parameters we were not getting uh, addressed in case of working stress method. So that's why it is the limit state of serviceability. Now we can understand here that structure has not collapsed, but providing discomfort to the occupants and failed to fulfill the intended purpose for which it is made up. Now, let us sum up it. The attainment of one or more ultimate limit states. So we have discussed two limit state of collapse or limit state of serviceability. So here, the attainment of any one of these states may be regarded as the inability to sustain any increase in load, whereas the serviceability limit states that it denotes the need for remedial action or some loss of utility. So that means if your structure which you have designed is reaching the limit state of collapse, that means now it is not able to sustain any type of load. After that, it will collapse. Whereas when we are talking about the serviceability limits, serviceability limit indicates that there are some remedial corrections need to be taken so that it should not lose its utility. Therefore, ultimate limit state or limit state of collapse are conditions to be avoided during the design, and serviceability limit states are the conditions that are undesirable. Therefore, in a limit state method of design, we are governing the safety of structure during and before its use by designing the structure such that to assure that we have to make it sure that the probability of reaching any limit state is acceptably low. That means when you are going to design by using limit state method, then we have to be assured that any type of limit state will never reach. So we have to design structure accordingly. We will be choosing the section, selecting the material, as well as applying various type of checks. That checks may be related to strength, that checks may be related to deflection, some crack width, or any type of leakage, durability, etc. So all these things we have to take care while designing any RCC structure with the limit state method. Thank you. So students, welcome to lecture number 5 in the series of design of concrete structures. Earlier up to lecture number 4, we have discussed some properties of concrete which are most relevant in the design of concrete structures. Then we have discussed limit state methodology of the design. That means information regarding two type of methods, working stress method as well as limit state method. So in limit state method, we have discussed that there are two type of limit states. Number one is limit state of collapse, and the second one is limit state of serviceability. So I hope that you are all aware regarding the basic concept which we have discussed, and you have watched all the 4 lectures carefully, and I'm happy that many of you are directly asking the questions in the comment section, and as per the time availability with me, I'm trying my best to reply your queries. So today in lecture number 5, let us discuss what we are going to discuss today. So first of all, some information regarding limit state design method as per IS 456-2000. We will also discuss regarding the characteristic strength as well as loads which any building is going to encounter. So what are the various materials which are to be used in case of RCC structures, and what are the various type of loads which we are going to consider in the design as well as analysis of the RCC structure. Then we will go through the various partial safety factors which are to be used in case of limit design methodology as per the recommendation of IS 456. Then design strength as well as design loads which are to be taken in the calculations for the design of the RCC structures. So let us continue. So, limit state method of design of RCC structure. Today's topic is loads, which we are going to be considered in design calculation when any RCC structure member you are going to design. So let us go through the details. Now, what are the loads which we are going to consider? So first of all, the determination of various type of loads which a structure may experience during lifetime, as well as combination of loads which are required to be decided based on the probability occurrence in the light of guidelines suggested in standard. So what is the purpose of or what it indicates? That whenever you are going to design a structure, that means you will be going to do some calculations based on which you will be able to just work out the cross section as well as the material requirement, type of material, etc. So all the information we are going to enlist in case of design calculations as well as the drawings which will be the supporting the design. Now various type of loads which any structure will be expected to be experiencing during its lifetime. So that means we are not aware, or we can't say exactly what will be the load which a structure will be going to encounter. So that means based on the probability of occurrence, we will be going through, first of all, assuming the various type of loads based on the geographical region where the building is to be located and all the other parameters which we may later on take into consideration. So there may be various type of loads. So during design, we have to take into consideration combination of loads. Later on you will be able to understand that what is the meaning of combination of loads. And all these loads are based on the probability of occurrence. And with this probability of this information, we will be taking care with the help of the IS guidelines, that means Indian Standard Codes. The probability that a specific load will be exceeded during the life of a structure usually depend on the period of exposure, that means the life of the structure, whether that specific load, any type of load, can exceed its limits which we have taken into consideration while designing of the structure. It depends on the exposure of the structure, how much lifetime you are going to be expecting for a particular structure when you are going to design, as well as the magnitude of the design load. Then load need to be considered in design calculation. They depend upon the location as well as type of the structure. Such as when you are going to consider wind load, when you will be taking consideration of the wind load in the design calculation, that depends on whether the structure is located in such type of area or such type of zone where wind load are expected to be predominant. As well as similarly, we can talk about the earthquake load. Whether earthquake load is to be considered, that depends on the geographical region of the area where you are going to be constructing the building or any structure which you are going to design. So what load you have to take into consideration, that depends on the various factors. That means what is the type of the structure. Suppose there is a tower type of structure, that means having a greater height, then definitely wind load may be affecting it. But if you are just going to construct a building just as a residential, maybe single story, double story, you may ignore the wind load criteria depending on the location also. Now, in the limit state of design method, that means loads. So first of all, we will be discussing what is the dead load. So now let us go through the information. Dead load is the load which can be considered as fixed in magnitude and position, and that type of load will be termed as dead load. And this dead load you can assume based on the assumed dimension. That means when you are going to design any, suppose a RCC beam, so first of all you are not having information regarding the cross-section dimensions of the beam. So first of all, in the design methodology, in design steps, you will be going to assume some value for the cross-section dimensions of the beam. So according to the assumed dimensions, you may be working out that what will be the self weight of that particular beam or that section. So accordingly, that load which you consider that it is a fixed in magnitude and position, you will be considering or you will be terming it as a dead load, and its calculation can be, as I told, will be depending on the dimensions which you have assumed as well as the material of the structure which you are going to under design, whether it is concrete, whether it is steel or any other type of material. So based on the unit weight of that material and the dimensions of that material, you will be able to work out an assumption for the dead load. Now here we will be taking help of IS 875 part 1, that is code of practice for design loads other than earthquake for building and structures. So that means if you are going to design any building or structure and you are not considering in your calculation the earthquake load, that means the building is not in any earthquake zone where earthquake is frequently occurring. So for that you can refer for your calculations the guideline mentioned in IS 875 part 1. So what IS 875 part 1, it is for dead load, and you can collect the information regarding unit weight of building material and stored material. Now this is just a snapshot from the IS 875 part 1, just to illustrate what actually information, how actually we can get the information from the IS code. So this is IS 875 part 1 1987 version, just for illustration purpose. So you can go through the table number 1 and the table number will give the information regarding unit weight of building materials. And now you see here, if your building material is a cement concrete, it may be pre-stressed or it may be reinforced. So that means when you are going to be using cement concrete as the material, then unit weight will be taken as 2400 kg per meter cube. So by this information, that means better you are taking the unit kilonewton, then it will be 23.5. But normally we will be taking unit as kg per meter cube. Then you can take 2400 as kg per meter cube unit weight of the cement concrete. Accordingly, other type of information is available in this table number 1. I have just taken little bit information just for the illustration purpose. Now second type of load which are prominent in case of structures or buildings which we are going to be designed later on, that is imposed load. Now what are imposed load? They are also gravity loads other than dead loads, which may include items such as occupancy of people. That means later on the structure will be occupied by people, so their load, which is movable load, can be considered as imposed load. Earlier it was called as a live load. So any equipment which you can consider that it can be movable, not fixed. Furniture within the building, movable material which is stored such as books, machinery, whatever be. So imposed load means it is a live load, and that load can be removed. That means it is a movable, it is not a fixed type of load. So that type of load will be termed as imposed load. Earlier it was already told that it was termed as live load. Now there are different type of buildings. So these type of imposed load may be different for different type of building as per their use or as per their purpose for which they are built. Second point which we can take into consideration, they are generally considered as static load for convenience of calculation. There may be a little bit dynamic effect of imposed load also, but for calculation, for the simplicity of the calculation, we are not going to take into consideration that dynamic behavior. So you can consider while doing the design calculations. So dead load as well as imposed load, they both are taken as static loads. Indian Standard Code provide uniformly distributed loads as well as concentrated load for various occupational categories. So you can refer the Indian Standard Codes for various type of category of loads. The distributed and concentrated imposed load shall be considered separately, and the design carried out for the most adverse conditions. So here you will be come across the term combination of load later on. That means when you are going to design a structure, you have to take the combination of load and you have to follow that combination of load which is going to offer most adverse condition, so that our structure should be designed for adverse possible conditions which may happen during its lifetime. Now refer here, this is IS 875 part 2. Now this code gives you the guideline, and the title of the code is Code of Practice for Design Loads other than earthquake for building and structures. So in this IS 875 part 2, you can refer table number 1, and table number 1 is for imposed floor loads for different type of occupancies. Now see here, you can refer here, they have enlisted listed the occupancy types. Now if there is a residential type of building, it may be a commercial type of building. So accordingly UDL as well as concentrated load value you can take for your design calculation, as they have mentioned just a snapshot, a little bit information. Dwelling houses, all room and kitchens, you can take UDL as 2 kN per meter square as well as 1.8 kN for concentrated load. Now you can see here unit system you have to take because it is concentrated load, so it is unit will be kilonewton, and when there is UDL, uniformly distributed load, then a unit will be kilonewton per meter square. So IS 875 part 1 we refer for the dead loads, and IS 875 part 2 we will be referring for the imposed type of loads for building and structure. Here you have to be clear that no earthquake consideration will be taken. For earthquake type of loads, you have to refer a special code, that is IS 1893, and maybe during our design theory which we will be going through later on, earthquake type of load may not be considered. Now let us briefly discuss about the combination of the loads. So as per IS 456 recommendations, code has given these three type of combination of loads: dead load plus imposed load. That means whatever be the dead load and imposed load, first of all you will be adding them and you will be working out some quantity. Then second will be dead load plus wind load or earthquake load. So it is very much sure from the past experience that whenever there is a high wind velocity, wind is blowing with a high velocity, then possibility of earthquake is negligible. So that means they both type of loads need not to be considered simultaneously. Either you can consider wind load or you can consider earthquake load. Third type of combination of load is dead load plus imposed load. and plus wind load. So when you are going to do the calculation for various type of combination, and whatever be the adverse type of load, or you can say highest value of the load, that will be considered for the design purpose. Now we are going to discuss some codal recommendations listed in case of a limit state method of design, and you can refer clause number 35. That section is totally devoted to limit state method in IS 456. Now some of the terms which we are going to use in limit state method. So let us go through these terms. Now very first term which we are going to use, and that is clearly mentioned in clause number 36.1 of IS 456, that is the characteristic strength for material. As we have gone in detail regarding the characteristic strength of concrete, so here we are using two types of material, and the concrete as well as steel. So what code is mentioning, or code is suggesting, that can be referred in clause number 36.1, and let us go through just a revise characteristic strength for material. Now when we are talking about concrete, so the characteristic strength of concrete is the strength of concrete below which not more than 5% of test results are expected to fall. We have gone through this information in earlier lecture 1 or lecture 2. If you still have any doubt, you can refer previous lectures, and you can refer table number 2. Now in IS 456 table number 2, which can be referred for different grade of concrete. So that means according to the different grade of concrete, what is the characteristic strength, that is clearly mentioned in table number 2. Second material which we are going to use in our CC structure, that is steel reinforcement. So the characteristics value shall be assumed here as the minimum yield stress or 0.2% of proof stress, which is specified in relevant Indian standard specification. So you are I think you are well aware regarding the concrete, because all these information we have discussed in the preliminary lectures, and regarding the steel reinforcement, that already has been discussed in strength of material. Now let us go through this table number 3, and this code is IS 1786 2008 version. So what table 3 give us information regarding the mechanical property of high strength deformed bars and wires, which we are going to use in case of design of RCC structure. Earlier there was a mild type of steel, that is mild steel. Nowadays we are not using mild steel in case of RCC structures. Now table number 3 give us information regarding the high strength deformed bars, and this is the grade of the steel which from which these reinforcement bars are manufactured. It may be Fe 415, 415D, 500, 500D, 550, 550D, and 600. Now this 600 has been included in the latest revision in this code. Now 0.2% of proof stress or yield stress, this is the minimum value. So mechanical strength, that means the yield strength which we will be taking, if you are taking Fe415 steel into design, then you will be taking its yield strength, minimum yield strength, that is 415 MPa. So accordingly there are various type of grades of steel, and accordingly you can take the value of the yield strength of that steel for your design calculation purpose. Another important thing which you have to take into account, that now the nominal size of the reinforcement bars which are available as per the code, now these are the 4 mm, 5 mm, these are the diameter of the bars which you are going to take into consideration while designing 8 mm, 10 mm, 12 mm, Earlier there was 22 mm dia bar also, but now they have removed in the latest revision in the code. So I'm not going into detail what are the various revision. So these nominal diameter bars are available in the market, or they are manufactured as per the codal guidelines. So whenever you are going to design, you can assume any type of, or you can take into consideration any type of any diameter of the bars from these values which are given here as per their requirement and as per their application, which you will be later on understand more effectively. Now another is earlier we in the previous slide we have gone through the characteristics strength. Now we are focusing on characteristic loads. So for this information is available in clause number 36.2. So let us briefly discuss this. The characteristics load is defined as the load that has 95% probability of not being exceeded during the life of the structure. So what we are considering here as per the definition, that means characteristics load will be that load which has 95% probability. That means there is the probability or possibility, 95% of the possibility that it will not exceed during its life of the structure. So that load you will be taken into consideration in the calculation purpose. That will be the termed as characteristic load. Now code is saying that in case of or in the absence of any statistical data regarding load, nominal values specified for dead load, live load and wind load can be taken from these code IS 875 part 1, part 2 and part 3. And the value of seismic load, that means when you are going to consider earthquake load in case of design, then you can refer IS 1893 2002. So till this we have discussed what are the characteristic strength and what is characteristic load. Now we are going to focus on design strength. Now we have switched over from characteristic strength to design strength and characteristic load to design load. And for this we can refer clause number 36.3 of IS 456. The design strength of concrete or reinforcing steel, that means design strength of the material, is obtained by dividing the characteristic strength, which we have already discussed, by the appropriate partial safety factor. Earlier in the introduction part of limit state method, you may remember that we have discussed here that instead of a working stress method where we were using factor of safety, in limit state method we are using partial safety factor. And this partial safety factor depends on various factors which later on we will be going to discuss. So when you have to calculate, you have to find out the design strength of any material, then what you have to do, you have to just divide the characteristic strength, take the value of characteristic strength of that material, and by appropriate partial safety factor, by applying various considerations which we will discuss in the coming lectures. Now design strength and design load. First of all, partial safety factor in limit state method, and symbolically we will write it as gamma. Now first of all, partial safety factor for material. So you may be able to understand that here we are going to take partial safety factor different for material as well as for load. So first of all, this is gamma m. Gamma is partial safety factor and m is used to indicate the material. So gamma m is partial safety factor for material. And for concrete, as mentioned in Indian Standard Code, we will be taking partial safety factor for concrete 1.5, that is gamma c is equal to 1.5, and partial safety factor for steel will be taken as 1.1. 1.15. Gamma S is 1.15. So you can see here we have taken partial safety factor for concrete somewhat higher than partial safety factor for steel. So here why we are taking this, you can refer any standard material, and this will be the first question for all of you. So you can just get the information and write in the comment section. You can refer clause number 36.4.2 of IS 456 for partial safety factor information regarding the material. Next is partial safety factor for loads. Here we are using symbol gamma F. Here we were using symbol gamma M. Gamma M for material and gamma F for loads. So gamma F, that is partial safety factor for load. It is the partial safety factor value for various combination of loads. Now here you can see here that we are using various type of combination of loads which we have discussed in the previous section for ultimate limit state and for serviceability limit state. So that means you have to take the partial safety factor for loads different for different type of combination of loads and different value for ultimate limit state as well as serviceability limit state. And information is available in table number 18 and clause number 36.4.1. Now this is the table number 18 which we have taken from IS 456. So value of partial safety factor gamma F for various type of loads. As we have discussed here that various type of load combination we are going to discuss. These are the combination of loads. So here as the combination of load change, partial safety factor will change. So various type of combination of loads: dead load plus imposed load, dead load plus wind load, dead load plus imposed load plus wind load. Now see here in note it is mentioned while considering earthquake effect, substitute EL for WL. So that means either take EL or take WL. Now in second column you can see that these are the value of partial safety factor for limit state of collapse, which we have termed as ultimate limit state. So dead load, imposed load. If you take into consideration first combination of loads, that is dead load plus imposed load, then you have to take this value. That means for dead load, partial safety factor gamma F is 1.5, and for imposed load it is also 1.5. And if we are taking into consideration wind load, then partial safety factor we will take 1.0. Now if you are going to discuss, take the value for limit state of serviceability. So this partial safety factor for dead load, which was 1.5, here you will take it as 1 for this type of combination, and imposed load 1, and wind load it is not specified in the code. So accordingly, what are the various type of combination of loads you are taking into consideration? Accordingly, partial safety factor are mentioned. Now here another question which I want to ask to all of you, so that you can just grill yourself and you can refer some standard material. Now here if I say this is A type of combination of load, and this is B type of combination load, and this is C type of combination of load, you can see here we have taken different values for partial safety factor for dead load in case of first combination, second combination and third combination. Why we have taken so much variation in the, or in other language we can say why the partial safety factor is varying from 1.5 to 0.9 or 1.5 to 1.2. So why it is decreasing when you have changed the combination of load, type of combination of load. So this question is for all of you who are going to watch this video, and you must go through some literature or some standard book and just write your in the comment section your reply. And similarly for serviceability limit you can consider also. And the third question which I want to ask you, suppose we are taking this first combination of dead load plus imposed load. In limit state of collapse we have taken partial safety factor 1.5. for that load. But in limit state of serviceability, we are taking the value 1. Why this variation in the partial safety factor is taken into consideration? That means why lesser partial safety factor is taken in case of limit state of serviceability, and why higher value is taken in case of limit state of collapse. So I am expecting all of you go through the lecture carefully, as well as the 3 or 4 questions which I have asked. You must reply uh, in the comment section of the YouTube video, which I am going to upload later on. Now limit state method of design here, some more information, that is design strength and design load, how to do the calculation for it. So as already discussed, design strength of concrete or steel can be calculated by, or can be evaluated by dividing characteristic strength by appropriate partial safety factor. So when you are going to calculate or evaluate the design strength of material, it may be concrete or it may be steel. So we will be going to use this formula, which is available in IS 456 in clause number 36.3 onward. So here F is the characteristic strength of the material, and gamma m, as we have discussed, partial safety factor, which is appropriate based on the material and the limit state being considered. I think you are able to understand that what is the meaning of appropriate to the material and limit state to be considered. It indicates that limit state, whether you are taking limit state of collapse into consideration or a limit state of serviceability. Accordingly, you have to pick the value gamma m. So what we are doing here, we are just taking in the design calculation. That means if you are here material is, suppose it is concrete, then design calculation, we are taking the design strength of that concrete is lesser than its actual characteristic strength. So we are applying partial safety factor here. In earlier lecture, I have explained you that what is the use of partial safety factor, why we are taking partial safety factor. So here question number 4 comes out to be, what is the role of partial safety factor in case of material we are taking? That means what is the significance or why we are taking partial safety factor of material into consideration? So that answer I am expecting from all of you, those who are listening the lecture, they should write in the comment section. Now design load, here we have taken capital F for the symbolic purpose. Capital F is for the load and D for the design. Here F, which is a characteristic load, is multiplied by partial safety factor appropriate to the nature of loading and the limit state which you are going to be considering. So here we are multiplying the design load, but in case of design strength, we were dividing the characteristic strength by partial safety factor. So that means we are taking strength at a lower side, but design load as at a higher side. So here that means we are again uh, assuring the, you can say assuring the that there should not be any type of a failure in the design. That means when you are going to design a structure, you are doing the calculation, you are taking strength at lower end but load at higher end, so possibility of failure will be automatically reduced. Thank you.